We can also test for differences between the population proportion in the same way that we tested for differences between means. Here are a few examples. Let's assume we have a survey of employee satisfaction and 70% indicate that they are satisfied. Then a few months later, after some training programs, we want to see if the satisfaction rate of 75% is really different from the original test. Another example would be taking a clinical trial of a drug in which 35% indicated improvement in their condition, and we might check this against a placebo group that had indicated 20% improvement with the placebo drug. Or proportion of Democrats or Republicans in a sample that indicates satisfaction with government policies. 1 year later, a similar group is examined to see if the proportion of satisfaction has changed. Remember, since we're working with population proportions, we're going to be using a Z statistic. So we set this up again, and we have an example here, and we have the formula all the way to the right for calculating the Z statistic. The Z statistic is going to be calculated using Z equals P1 hat minus P2 hat, which is the proportion of success in sample 1 minus the proportion of success in sample 2. And we're going to put that over the standard error of the difference between the two. The formula for the standard error between the two is given by the formula in the middle here. The square root of the pooled proportion, which is denoted by PC. Now, how do we calculate this PC? It's equal to the pooled proportion. So we add up the successes of sample 1 and sample 2, which would be 70 and 237, and that would correspond to the 70% and 78% success in both samples, and we divide that by the total population that we have, which is the sample 1 and sample 2, which is 400, and that would give us 0.768. So as we had said before, the standard error of the difference in proportions is equal to the square root of this pooled proportion, PC, times 1 minus PC, times 1 over N1 plus 1 over N2. So when we set all this up, our hypothesis test is down below as P1 hat equals P2 hat. Our alternative is that they're not equal to each other, that these two proportions are not equal to each other. When we calculate our standard error of the difference, we end up with a number of 0.0487, and we will plug that into the denominator of the Z statistic. Our numerator is the difference between the two, and we end up with negative 1.85. We'll take the negative 1.85 and put it into the norm.s.dist, true, for the cumulative distribution, and we end up with a value of 0.033. Since 0.033 is less than 0.05, we can reject the null hypothesis and state that there is a difference between the proportions.